Early next year, an international team will track the uncontrolled atmospheric re-entry of Tiangong-1, China's first prototype space station. An artist's conception of Tiangong-1 in orbit. CM Sekina Space Engineering Office. A large, uncontrolled re-entry is set for early 2018, as China's first prototype space station, Tiangong-1 Chinese 4 Heavenly Palace, is set to burn up in Earth's atmosphere during its fall from orbit. China's National Space Agency CNSA launched the school bus-sized, 8.5-ton space station on September 29, 2011. It was the precursor to a full-scale space station that China is planning to complete by 2022. China used the precursor station to test automated docking and rendezvous techniques in November 2011, followed by 2 short visits by taikonauts, Chinese astronauts aboard Shenzhou 9 and Shenzhou 10 in 2012 and 2013, respectively. China extended the Tiangong-1 mission out to March 2016, but ground controllers lost contact with it late last year. In May 2017, China stated in a letter to the United Nations Office for Outer Space Affairs that the station's altitude was decaying at a rate of about 160 meters (0.1 mile per day). The letter also stated that orbital status and other information relating to Tiangong-1 will be posted on the website of the Chinese Space Agency. Meanwhile, China launched the slightly larger Tiangong-2 on September 15, 2016. This temporary station serves as a test bed for new technologies, in preparation for the more permanent Tiangong-3, planned for launch in 2019. China has charged forward with its own space station in part because it is a conspicuously absent player in the International Space Station program, as international traffic in arms regulations currently prohibit a U.S. government agency such as NASA from sharing restricted technology with China. But the Tiangong launches are just part of China's space efforts. The nation's space agency recently finished testing its new Tianzhou-1 automated cargo vehicle during rendezvous with Tiangong-2. It has also developed a Long March 5 heavy-lift rocket, which will deploy the Change 5 lunar sample return mission early next year. Shenzhou 10 docking with Tiangong-1 on June 13, 2013. CCTV Re-Entry Observing Campaign. CNSA officials will work with the Interagency Space Debris Coordination Committee (IDC) leading up to Tiangong-1's re-entry. The IDC, an international forum of 13 space agencies concerned with issues related to space debris mitigation and management, will use the impending event as part of an upcoming campaign to improve prediction accuracy. Tiangong-1's 300 km high orbit is inclined 42.8 degrees to Earth's equator, which means its re-entry will occur between latitudes 43 degrees north and 43 degrees south, a pretty wide range. The date, time and geographic footprint of the re-entry can only be predicted with large uncertainties, says Holger Krag ESA in a recent press release. Even shortly before re-entry, only a very large time and geographical window can be estimated. Monitoring space debris. In addition to potential problems during re-entry, space debris can pose a hazard to spacecraft and humans in space. Many organizations monitor space debris, both large and small. ESA tracks active and inactive satellites as part of its Space Situational Awareness program. The U.S. Air Force has deactivated its space surveillance system known as Space Fence in 2013 as it transitions to Lockheed Martin's next-generation system, set to come online in 2019. U.S. Air Force Space Command currently maintains space situational awareness using surveillance radar based out of Eglin Air Force Base, Florida, and Cavalier Air Force Station, North Dakota. Another asset which keeps track of space junk optically is the Meter-class automated telescope MCAT based on Ascension Island in the South Atlantic. The decay of Tiangong-1 over time. Crisp heavens above Tiangong-1 is one of the largest objects to re-enter Earth's atmosphere in recent years. The 7.2-ton upper atmospheric research satellite UARS satellite re-entered on September 24, 2011, and the last large space station to re-enter was Russia's 143-ton Mir on March 23, 2001. The California-based Aerospace Corporation is currently projecting Tiangong-1's re-entry to occur in early February 2018, give or take a month. As we approach that time, expect the window to narrow. Atmospheric drag and solar activity play a role in speeding up or slowing down re-entry for satellites in low Earth orbit. Currently, the U.S. Joint Space Operations Center's JSPOC space track site ISNT listing Tiangong-1 in the re-entry queue. Another re-entry we're anticipating is the crippled Japanese Hitomi X-ray satellite, which fell silent in March 2016. Tracking Tiangong. Spotting Tiangong-1 during dawn or dusk passes is easy, as the station is typically as bright as Sirius, at a magnitude of -1. Tiangong-1 glides through Orion over Williamsburg, Virginia. Chris Beck of Physics Heavens Above has a link on the homepage dedicated to Tiangong-1 and Tiangong-2, and a series of good evening passes for the southeastern U.S. For Tiangong-1 Air coming up starting on November 21st. He'll be curating these on Twitter in the hours leading up to each pass. It'll be interesting to see how the Tiangong-1 re-entry story unfolds, and where on Earth the historic station will finally meet its demise. Tiangong-1's orbital track